Since 2004, CREALYST has been the expert in vessel loading optimization. This video stands to explain how fluids behave depending on different filling methods. Let's take a liquid as an example: water. No matter how you fill a container with water, whether it's a rain fill or a jet fill, the volume of water remains the same. Now, what about divided solids like grains, pellets, or catalysts? A standard filling method is the sock loading technique. The particles form a tangled structure with lots of empty spaces. This irregular structure can lead to uneven flow when a fluid passes around the particles. CREALYST recommends an optimized filling method called HDL, homogeneous dense loading, which works on automatic control. The rain method ensures a homogeneous and regular organization of the particles. With such process, larger mass can be loaded into the same vessel volume with a density gain of up to 28%. In addition, the regular particle arrangement with flat and horizontal bed ensures optimal use of the catalytic mass. To achieve this level of quality, a flat and horizontal fill throughout the process is essential. What happens when a slope appears on bed upper surface? A slope introduces irregularities. Close to reactor wall, a tangled structure with large void volume appears. In the reactor central part, the structure is more dense and compact, with accumulation of dust and small-sized crushed particles. Such differences produce preferential channeling appearing when reagents flow through, enhanced with some accumulation of coke. This phenomenon appears with conventional sock loading and lower-quality non-homogeneous dense loading. Now let's have a look at the real-world consequences of filling your installation. With the sock method, the formation of slopes and random arrangement creates zones that are denser than others because of the presence of fines. Sending people inside the reactor is necessary. This increases the risk of accidents. With the HDL method, no human intervention is required inside the reactor. The loading is controlled, consistent, and flat throughout the process operation. This homogeneity allows for up to 28% more space efficiency, so you can either fit more catalyst into the reactor or occupy less volume for the same amount loaded. Once the reactor is in operation after a sock loading, the product tends to create preferential channels through the catalyst bed, where the density is lower, leading to irregular temperature increases known as hot spots and resulting in partial local damage of the catalytic mass. On the dense side, thanks to a homogeneous pressure drop throughout the catalytic bed, the fluid reacts uniformly when in contact with the catalyst. This not only increases catalytic activity, but also extends catalyst's lifespan and product overall production.